Today we will be using several methods of factoring. We have 4 problems to look at. On the far side here, I have a listing of steps that I look for. The first thing whenever I'm factoring I look for is a GCF. I do not have a GCF that is common to all 4 terms. So I move on to see if I have a binomial, which I do not. And then I continue down to see if I have a trinomial, and I do not. So now I'm down to the grouping method. So when I'm looking for a grouping method, I'm going to be looking for hopefully something that I can turn into a perfect square trinomial, or possibly a difference of 2 squares, or lastly a GCF. When I look at problem number 1, I notice I have an x squared and an x, and I have this lone 4y squared. That's giving me a hint that I should put maybe my x's together. And because I'm going to put my x's together, I'm going to be shooting for a perfect square trinomial. Hopefully, if I put these 3 terms together, I'll end up with a perfect square trinomial. And then I'm going to drag the 4y squared at the end. So I've grouped this as a 3 by 1. A 3 by 1 perfect square trinomial is here. And I have a perfect square over here. So when I do the perfect square trinomial, I end up with x minus 2 the quantity squared minus 4y squared. And this is very nice. Now that I have factored my perfect square trinomial into this format, and I do not have to factor this one, I notice that now I have 2 terms. So now, since I have 2 terms, I have a difference of 2 squares occurring. A difference of 2 squares I will factor in this manner. One will be a plus, one will be a minus. This will become x minus 2 because it's a perfect square and I need 2 of them. Over here I have 4y squared, and I take the square root of that and I end up with 2y. And I place that in those 2 locations. This is my final answer. Alright, continuing on to problem number 2. I'm going to be looking for a GCF at first. And when I do know it, I do see that I have a GCF of an n on both of these. But I also know that I have a difference of 2 squares occurring in my first term. So before I start to factor the whole item, I am going to just factor that first portion. Now when I've done that, very nice, because now I can see I have a GCF of n and n minus 1. So I'll pull out both the n and the n minus 1, and that will leave me with n plus 1, and then I also have a 1 left here. So I end up with that. This is not simplified completely, so I will continue. I will have n plus 1, which becomes n plus 2. At this point when I look, I go through my checklist here. I see that this is completely factored. When I look at example number 3, starting again with the GCF, I look at all 4 terms. And when I look at all 4 terms, I see that I do not have a GCF. So I continue to a binomial. No, it's 4 terms. So that also means that it cannot be a trinomial. So I'm down to my grouping method. When I look at my grouping method, I am going to note here these first 2 and last 2 do have a GCF occurring. My first 2 terms have a GCF of 4a squared. When I pull out the 4a squared, I'm left with 2a plus b. When I look at my second term, I notice I have a minus and a minus here, but I know that I need a plus in this term. So I'm hoping that I can get something that looks like this. So I am going to factor out a negative, or the opposite of b squared. When I pull the opposite of b squared out, I end up with a 2a plus b. This works out very well because, again, I have a GCF in those two terms. So I'm going to pull out my GCF of 2a plus b, and I'm left with a 4a squared minus a b squared. When I look at these, I start again at the top of my list, check to see if I have a GCF. I do not. Do I have a factorial binomial? Yes, I do. I have a difference of two squares occurring right here. So I have to continue factoring. So I pulled my first factor down, and I factor my second factor into 2a plus b, 2a minus b. Again, I start at the top of my list, check off each one of these, and note that I do not have any of those things occurring. So this is my final answer. Thank you for watching. Your notes are completed.